Hello everyone, my name is Spencer Lamb and here's my video for the BioLab. And in today's video we'll be talking about eDNA or environmental DNA. So sit back, relax, and enjoy the video. Alright, so one of the questions you might be asking is, what is eDNA? And eDNA or environmental DNA is the DNA that all organisms leave behind as they interact with the environment. Or in other words, it refers to all the tiny traces of genetic material that is left behind as living things pass through water, sediment, or the air. And now I'll be showing you some real-life examples of what eDNA looks like. Alright everyone, we are back. There's no better place to be filming this than at Aldrich Park, which is where we are at right now. So if we take a look at our surroundings, there's a lot of signs of eDNA. So the most obvious example that I can point out is the ground. And the ground has sediments and soil, which is filled with nutrients. And that's a good example of eDNA because we can extract a lot of DNA just from that. So a way that plants can contribute eDNA is through decomposing leaf litter. And if we look, there are plenty of decomposing leaves all around us, and these are great examples of eDNA from plants. An example of how animals can contribute eDNA is through shedding skin cells, feces, urine, saliva, and mucus. And lastly, fungi can contribute eDNA with the release of spores. Alright, so now that I've gone through a quick overview of what eDNA is like, now I'll be explaining some of the factors that can help accelerate the degradation of eDNA. And some of those factors include mechanical forces, UV, microbial action, heat, enzymes, and acidity. Now, let's talk a little bit more about biodiversity. The definition of biodiversity can be summarized like this. It is the variety of life in the world or in a particular habitat or ecosystem. Now, with that being said, a particular habitat or ecosystem strives for higher diversity. And high diversity means that there are diverse functions that can be performed. A diverse system can do more things and can adapt to environmental changes better. And there's also a high resistance to invasion and disease. Alright, so there are two ways of measuring species diversity. The first one is alpha diversity, and the second is beta diversity. So I'm going to be talking about alpha diversity first. And what it is it describes the species diversity within a community at a small or local scale. And there are two parameters involved, richness and evenness. So now I'll be using the Rubik's Cube as my analogy in this video. Alright, so as you can see here, we have our Rubik's Cube community. And the first common parameter to measure diversity within one site is richness, which is the number of unique species. So as you can see, there are a wide range of cubes here actually. So if we count up, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 unique puzzles, meaning that we have a species richness of 8. Now let's say you have the same community and you remove all the unique species. Now if you look at the same community, you would have a lower richness level because all of them are 3x3 Rubik's Cubes. Now the second common parameter to measure diversity within one site is evenness. And evenness is how evenly distributed the different species are. So in this community given right here of Rubik's Cubes, it is very rich, but it's not even. It's rich because there's still a unique amount of species, but it's not even. So an example of evenness would be like this. This right here would be an example of evenness because there are 3 3x3 Rubik's Cubes and there's 3 2x2 Rubik's Cubes. So a popular way of measuring alpha diversity is through using the Shannon Index, which is a popular metric in ecology that is used to estimate species diversity. And when it does, it takes in account of both the number of species living in a habitat, or the richness, and their relative abundance, which is the evenness. And the second type of diversity is beta diversity, which describes the species diversity between two communities or ecosystems. And what it does is it provides information of the similarity or dissimilarity of those two ecosystems or communities. And basically, the more organisms the community share, the lower the beta diversity. All right, everyone. So here's a quick summary of what we talked about today. So we talked about eDNA, which is environmental DNA, which is the DNA that all organisms leave behind as they interact with the environment. Then we gave some real life examples at Aldrich Park with plants, animals, and fungi. And then after that, we talked about factors that can accelerate the degradation of eDNA. And then from there, we went to talk about biodiversity. And after that, we talked about high diversity and then alpha diversity, with richness and evenness being involved in alpha diversity with the Shannon index. And lastly, we talked about beta diversity. Thanks for watching this video. I hope you learned a lot, and I hope you enjoyed it as much as I enjoyed making this video. Woo! Let's go!